All right, ladies and gentlemen, finding rate of change from a word problem. Okay, this has a couple parts to it. Larry's Lawn Service is mowing lawns today. By 10 a.m. they have mowed 3 lawns. At 12 they had mowed 7 lawns. The first question is, what is the dependent and independent variable? Okay, so dependent is just like it sounds. One depends on the other. Okay, so in our situation, what are the two things we have? Well, we have lawns mowed. Let's say lawns mowed, and we have time. Okay, now which one depends on the other? Does the amount of lawns depend on the time, or does the time depend on the amount of lawns? Okay, well, hopefully you figured out that the lawns depend on the amount of time, so they couldn't get like 7 lawns done in 0 time. It takes them a couple hours here. So lawns mowed depends, the amount of lawns mowed depends on the time. The time is independent, and you can think about this. You know, they could start at 7 a.m. if they wanted to, so that could change. But the amount of lawns mowed depends on the amount of time they put in. Just kind of like your pay would depend on how many hours you work if you're paid hourly. So that should say dependent. The lawns mowed is the dependent variable. The time is independent. Okay? What is the rate of change is our next question. And rate of change is just a code word. Anytime you hear rate of change, you need to remember slope. You need to remember this. iStep is always going to probably use rate of change. They're not going to use slope. They're going to say rate of change because they're trying to make sure you understand that rate of change and slope are the same. So I'm going to use my slope formula. Well, turns out the dependent variables are always x's. Okay? And the independent are the, oh gosh, I always do this. I got it backwards. The dependent are always the y's, and the independent are always the x's. Okay? So the x's are independent. Independent is time. So that means our time is going to go on the bottom. Well, on the time, you could do this. You could do 10 a.m. minus 12 a.m. But you got to be careful whenever you do time, especially if you start at like 10 a.m. and went to 4 p.m. That's going to mess you up. So just how many hours is 10 to 12? Well, it's 2 hours. So that's going to be your denominator. If you subtract the hours, you get 2 hours. On the top are your y's. Okay, your dependent lawns mowed. How many lawns do they mow? Well, if I started with 10, that pairs up with 3. That's the ordered pair. 10 o'clock, comma, 3 lawns. And so 3 minus, and then this one is 12 o'clock, comma, 7 lawns. So this would be 3 minus 7. Well, that is negative 4, which seems a little strange, right? Oh, 10 minus 12 is negative 2, by the way. That should be a negative. Okay, so those both turn positive, 4 over 2. That means 2 over 1, or what does this mean? Okay, so that means 2 lawns mowed per every 1 hour. That's what it means in context. It means the company mows 2 lawns in 1 hour. That's what it means. Okay, that's in context of the problem. Our rate of change is 2 over 1. But in context, it's 2 lawns every hour is what they're mowing. Okay, so that's how to find rate of change from a word problem. And if you're still a little confused on that one, feel free to ask me, and I'll be happy to explain that one a little bit more. So work well on this, and good luck.